All right, so our next section is X9, identify independent events. So looking at this diagram before we move into the questions. So an independent event is going to be, for example, we have A and B, so our blue and our red, they're independent. There's nothing that's going to be combined. So if you multiply this out, this probability of A and probability of B, it'll be equal to the total. So if you have like 1/2 A and the other half, 1/2 B, then that total should be 1. A and B, when it's dependent, there's going to be that section of shared properties. So where B and A are shared, it's at that middle point right there, that they're going to overlap. Okay. So let's see an example from this. Okay, so we're just trying to identify which ones are independent and which ones are dependent. So looking down here, for example, all right, let's keep this diagram up there. Deck of playing cards, you pull one card out, you put it back and you reshuffle the deck. That'd be independent or independent? That would be independent, because if you're going to reshuffle the deck, it doesn't really matter what that card was, okay? But if it's dependent, so that is going to be included in this yellow section here. So if you had 52 cards, you pull out one card and you do not put it back, then it's going to be dependent on you have basically 51 more cards. All right, so that's going to be a dependent event. All right, sample space is a set of possible outcomes. An event is a set of possible outcomes in a sample space. So let's look at one of them. Okay, in the experiment, the probability that event A occurs is 1/2. Probability event B occurs is 2/3. And the probability that events A and B occur is 1/6. Okay, so just to show the example, you're going to multiply 1/2 times 2/3. And that is not going to be equal. These are not independent events. Okay. Let's look at this next one, see if you can figure it out. Experiment, the probability that event A occurs is 5/7 of the time. Probably that event B occurs is 5/9. And the probability that event A and B occurs is 25/63. So pause the video, try it out. All right, so if you multiply these out, you should have got, let me just change my color. So you got A multiplied by B. That's going to give you 25/63. And then A and B. Oops. A and B they have there are the same. Okay, so this one would be independent. Okay. All right, looking at one more. And this one is going to be using the tables. So for a few weeks, music producer kept track of newly released songs on a music streaming website. You record the music genre, the number of times the song was played for the release date. Okay, the events are songs that have 0 to 500 plays. So that would be this category right here. And the songs was country. So looking at this column right here. Okay. I can almost, without even trying to look at the math, you know they're going to overlap. So country is going to be affected by the number of plays right there because they are going to cross, right? So this is going to be a no. Okay. But if you had to actually solve it out, here's how to do it. And I'll just show you the work from this example. Okay, so you add up all the total. It's going to be 25. You add all those up together. Event A is going to be 3. So we're going to cross right here, 0 to 500 is going to be 3/25. And probably event B is going to be 11/25. So I'll be adding up all the country music. And then the last one is going to be combined, is going to be 2/25. So the outcomes of A and B. All right, so in this case, P A and B is not equal to P times A times B. So A and B are not independent events. Okay, there's going to be some kind of overlap. As you can look at the table right there, they're going to share 0 to 500 plays and country right there. That number is going to be shared, so that means they're not going to be independent. They're going to be dependent on it at that time. Okay. The last subsection of this that we're going over today is going to be X10, find conditional probability. So conditional probability is going to be, for example, this one. I'll show you all the steps here. Experiment the probability that event A occurs is 3/4. Probability that B occurs is 3/7. The probability that events A and B both occur is going to be 3/8. So you're looking for what is the probability that A occurs given B. Okay. So that, if we're going to look down here, probability of A and B is going to be on top on the numerator, and then B is going to be on the denominator. So the probability of event B. Okay, so we're solving for A. So you're kind of looking for everything except A, right? So you're going to find both of them on top and then B on the bottom. Okay, so multiplying out 3/8 all over 3/7, and that's going to reduce down to 7/8. Okay, so the probability that event A occurs given that B occurs is going to be 7/8. All right, so let's look at another one. Experiment the probability that event A occurs is 7/9. Probability that event B occurs is 2/5. And the probability event A and B occurs is 3/8. So pause, try this one, see if you can get it. All right, so hopefully you had a chance to try it. So this one is going to be, your numerator is going to be 3/8. So I'm going to write this out. Oops. 3/8, and then that's going to be on the top, and then 2/5 is the probability of event B, right? And we're looking for probability A occurs given that B occurs. Okay, so 3/8 over 2/5. Let me clean this up a little bit. So remember, when you're dividing fractions, you can also flip the numerator and denominator. And then you can multiply it out from there. So 3 times 5, 15. And then 8 times 2 is going to be 16. So it's going to be 15 out of 16 is going to be your answer to simplify. If you want in a decimal form, that would reduce down, or that would give you 0.9375, but we're going to be looking for the simplifying any fractions. Okay, so it's going to be 15 over 16 on this event. All right, final problem we're looking at. The table gives a set of outcomes and the probabilities. Let A be the event, the outcome of the divisor of 3. So divisor of 3 is actually going to include 3 and 1. So for event A, it's going to be 1 and 3. Let B be the event, the outcome of divisor of 2. So 2 is actually going to include 2 and 1. Okay, because you can divide 1 by 2. And then we're going to find A and B. A if B happens. All right, so 1 and 3 are looking at 0.1 and 0.6. So 0.1 plus 0.6, 0.7. And then B is going to be 0.1 plus 0.3. That's going to give us 0.4. Okay. And the outcome if A and B, so they both have 1 in there. So that one is actually only going to be 0.1 because that's just going to include this number right up there. All right, and then where are we going to go from here? Well, we're actually going to try to do P of A and B is going to be on the top, which is going to give us 0.1. And on the bottom is going to be the probability of just event B happening. Okay. So we're solving for A here. All right, so the probability of event B happening is 0.4. Then we're just going to reduce it from here. So if you take away the decimal, that's what I would do. 1/4. 1/4 is the same as 0.25. So that should be your final answer on that one. All right. Last day, let's get it done. Nice job, guys.